Welcome to the presentation on day 50 of the Capstone project. Today we will be focusing on project planning and requirement gathering, laying the groundwork for a successful project. Let's get started. On day 50, we set the stage for our project by defining clear objectives. First, we need to select a project theme. You can choose between the three options: web scraper, data analyzer, or machine learning model. Next, we define the project's goals and outcomes. These goals should be clear and measurable. We also gather the requirements, including tools, libraries, and data sources, and lay out a project plan with milestones for coding, testing, and debugging. If you choose to work on a web scraper, the objective is to automate data extraction from websites. The outcome would be clean datasets exported in formats such as CSV or JSON that can be used for further analysis. Alternatively, if you choose the data analyzer, the objective is to analyze datasets and extract actionable insights. The outcome would be comprehensive analytical reports and compelling visualizations of the data. For those selecting an ML model, the objective is to build a predictive model for a specific problem domain, such as classification or regression. The outcome would be trained models with performance metrics that demonstrate the effectiveness of the model. Moving forward, we begin gathering the necessary requirements. For a web scraper, we will need tools and libraries such as Beautiful Soup, Scrappy, or Selenium. We will also need to identify the websites or APIs from which we will scrap data. For a data analyzer, we will utilize libraries such as Pandas, Matplotlib, and Seaborn for data manipulation and visualization. The datasets can be sourced from public repositories like Kaggle or UCI. For the ML model, we will use libraries like scikit-learn or TensorFlow. The data sources will be labeled datasets, which will be pre-processed before training the model. We will define inputs and outputs clearly to ensure smooth execution. Here's a high-level project overview. The plan is to divide it into several phases with milestones for each. We start with planning, moving to data collection, followed by development, testing, enhancements, and finally finalization. Each phase is aligned with specific tasks and days. While planning for the web scraper, we must consider potential risks. This includes website restrictions or data unavailability, which can cause delays or affect data collection. For the data analyzer, risks may arise from incomplete or noisy datasets, which can lead to misleading insights or errors in analysis. Though data cleaning is key to mitigating this risk. Similarly, for the ML model, challenges may include poor model performance or overfitting. To mitigate this, we can use cross-validation techniques, fine-tune hyperparameters, and ensure that training data is representative of the problem domain. As we reach day 50, we define the preliminary deliverables. By the end of the day, we should have the project proposal, the requirements document, and the project timeline, including milestones for all phases of the project. Thank you for your attention. If you have any questions or need further details, feel free to contact me. Remember, planning is the foundation of success, so let's get started on the right foot. Welcome to day 51, data collection and preparation. Today we will focus on preparing data for web scraping, data analysis, and machine learning projects. Let's dive into the crucial steps required to set up the foundation for your project. The objective for today is to acquire and pre-process data. This ensures that the data is ready for analysis or modeling. Whether you are working with web scraping, analyzing data sets, or building a machine learning model, cleaning and organizing your code is essential for reliable results. Here's a quick overview of the areas we'll be focusing on. Web scraper. We will learn how to extract and clean data from websites. Data analyzer. We will cover how to locate, clean, and explore datasets. ML model. We will prepare data for training and evaluation in machine learning models. For the web scraper, we will first set up scraping tools like Beautiful Soap, ScrapPy, or Selenium. After that, we will inspect the target website's structure to understand how to extract the data. Writing the initial scripts will allow us to collect sample data, and we will handle challenges like dynamic content and captchas. Finally, we will clean the data and store it for later use. For data analysis, we start by locating reliable datasets for sources like Kaggle or UCM. Once we have the data, we will clean it by handling missing values, removing duplicates, and ensuring consistent formats. Next, we will perform exploratory data analysis or EDA to analyze the data's distributions and correlations. Finally, we will visualize insights using tools like Matplotlib and Seaborn. For building an ML model, the first step is collecting and splitting the data into training, validation, and testing sets. After that, we will preprocess the data by normalizing numerical features and encoding categorical variables. We will also address any data imbalance using techniques like S-mode or undersampling to ensure balanced data for model training. Across all project types, there are some common tasks to ensure success. First, we will document each step of the process from data collection to pre-processing. It's also important to back up the data using Git or cloud storage. Finally, visualizing insights not only helps with analysis but also ensures transparency and supports decision making. By the end of day 51, you will have completed several important deliverables, scrapped or downloaded datasets, cleaned and pre-processed data that's ready for analysis or modeling, well-documented steps covering data sources, cleaning and pre-processing methods. Now that the data is ready, we can move on to the next step, core functionality implementation. This will begin on day 52. We have laid the groundwork and now it's time to build and experiment. Let's get started. Welcome to day 52, core functionality implementation. In this session, we will explore how to build the foundation for your project, whether it's a web scraper, data analyzer, or machine learning model. Let's get started. Today's objective is to develop and test the core functionality of your project. The focus will be on ensuring that your implementation is in line with your project goals and that is modular, reliable, and scalable. We will dive into each type of project and understand the steps involved in building the core features. Every project will have different core functionalities. For a web scraper, the focus is on automating data extraction and handling dynamic content. For a data analyzer, it involves cleaning the data and generating insights through visualizations. And for a machine learning model, we build a pipeline to train and evaluate models, experimenting with different algorithms to achieve the best results. Let's start with a web scraper. The first task is writing scripts to extract data using tools like Beautiful Soup, Scrappy, or Selenium. It's important to handle dynamic content and pagination properly. Then we clean and standardize the data, storing it in a database like SQLite or MySQL, or exporting it as CSV or JSON. Testing is crucial, especially for handling edge cases like broken links or rate limits, and error handling should be implemented to retry failed requests. Next, for the data analyzer, the first step is to load and validate your datasets. This could come from sources like Kaggle, UCI, or public APIs. Once loaded, data cleaning follows, where we handle missing values, outliers, and format conversions. Then we perform exploratory data analysis (EDA) using tools like Pandas, Matplotlib, and Seaborn to generate insights and visualizations. The goal is to detect patterns, trends, and statistical relationships within the data. For the machine learning model, we begin by preparing the data. This involves normalizing, encoding categorical variables, and splitting the data into training, validation, and test cases. We then implement the ML pipeline, which includes loading the data, training the model, and evaluating performance. Various algorithms can be experimented with, like linear regression or decision trees, to find the best fit. Testing and debugging are crucial, especially when addressing outfitting or underfitting issues. Across all project types, there are few common best practices. Logging and monitoring progress are essential for debugging. Version controlling Version control using Git helps in code management and collaboration, ensuring that all team members are on the same page. Additionally, backing up raw data and results is vital to avoid data loss, and automating periodic checkpoints will help in keeping track of progress. To summarize, Day 52 focuses on implementing the core functionality of your project. Whether you are working on a web scraper, data analyzer, or machine learning model, the key tasks involve writing scripts, cleaning data, testing, and ensuring scalability. By following these steps, you will lay the groundwork for a solid and reliable project. Hello and welcome to this presentation on testing and debugging for Capstone project. In this session, we will walk you through essential testing strategies, debugging common issues, and ensuring the reliability and robustness of your project. Let's start with the agenda. Today, we will cover key aspects of testing and debugging, including planning your testing strategy, conducting unit and integration tests, handling common issues, and testing edge cases. We will also discuss automation, logging, performance, stress testing, and how to prepare a comprehensive debugging support. To begin, it's important to plan your testing strategy. This involves deciding the types of tests you need, such as unit testing, integration testing, and system testing. You should also prepare for edge case testing, where we identify scenarios that could potentially break the system. With a well-structured plan, you ensure that every component works as expected. Unit testing helps ensure that individual components of your project work correctly. By testing each function independently, you can catch issues early in the development process. Tools like unit test or PyTest are often used for writing and running unit tests. For example, in a web scraper, we should test the HTML parsing function, while in a data analyzer, we test data pre-processing methods. Integration testing ensures that different modules of your project interact correctly. After validating individual components, it's crucial to check if they work well together. For instance, in a web scraper, you want to test if data is fetched, parsed, and saved seamlessly. Similarly, in a data analyzer, you need to ensure data flows smoothly from cleaning to visualization. Debugging common issues is a critical aspect of testing. For a web scraper, data fetching inconsistencies like timeouts or incorrect HTML structure can occur, but we can fix them with retry mechanisms or dynamic parsing. In data analysis, we may encounter incorrect visualizations, which can be addressed by validating data transformations before plotting. For ML models, you might face poor performance or overfitting, which can be tackled through feature importance analysis and model tuning. Edge case testing is vital in uncovering unexpected behaviors or failures. For instance, what happens when the input data is empty or malformed, or when the network connection for a scraper is interrupted. By testing these edge cases, we make sure your system is robust and can handle all types of real world scenarios, even the unexpected ones. Automation plays a key role in efficient testing. Tools like GitHub Actions or Jenkins can automate your testing process, ensuring that tests are run continuously and consistently. Additionally, logging helps track the performance and issues during testing. By implementing structured logging, you can capture important details that will help in debugging and improving the system. Performance and stress testing help evaluate how your system performs under heavy loads. For a web scraper, this means testing how the system behaves with multiple concurrent requests. For a data analyzer, we assess its performance when dealing with large data sets. In machine learning models, it's crucial to test training time and scalability to ensure the model can handle bigger data as it scales. A debugging report is essential for summarizing the testing process. This report should outline the test cases, results, and any fixes made during the testing phase. It's also important to highlight key issues and the steps taken to resolve them. Including logs or screenshots can help further document the issues and the solutions applied. In conclusion, comprehensive testing is critical for ensuring a reliable, robust system. By focusing on unit tests, integration tests, and edge case scenarios, we can address most issues early. Debugging common issues and automating tests will streamline your process, while performance and stress testing will ensure your system can handle real world challenges. Ultimately, a strong debugging report helps communicate progress and areas for improvement. That concludes our presentation on testing and debugging. I hope this session has helped you understand the importance of a well-structured testing strategy and the techniques for ensuring your project's reliability. Feel free to ask any questions or share your thoughts on the topic. Welcome to the presentation on enhancing features. In this session, we will focus on the advanced features, optimizations, and usability improvements you can implement for your project on day 54. Let's dive in. The objective of day 54 is to improve the functionality and usability of your project. You will cover enhancements across three areas: web scraping, data analysis, and machine learning. Our goal is to make the project more robust, user-friendly, and scalable. Starting with the web scraper, one of the primary enhancements we can implement is better data storage. You can integrate database support by using lightweight databases like SQLite or choose scalable solutions like MySQL or PostgreSQL. Additionally, allowing your scraper to export data in CSV, JSON, or XML formats will improve data accessibility and usability. Next, let's focus on error handling and logging. Implementing graceful error handling for network issues like 404s or 500s is essential. Using retry mechanisms we exponential with exponential backups, we ensure that your scraper is resilient. Additionally, utilizing Python's logging module will help you track issues and monitor scraper performance. In terms of feature enhancements, you can make your web scraper more efficient by supporting dynamic content through tools like Selenium or Puppeteer. Consider integrating multi-threading or asynchronous scraping for faster data extraction. And don't forget about scheduling periodic scraps so you can gather updated data regularly without manual intervention. While not essential, adding a user interface can greatly improve the experience. A simple command line interface or even a web interface would allow users to specify target websites, define scraping parameters, and select output formats. This makes your tool more flexible and accessible. Moving on to the data analyzer, one of the first improvements is modularization. By breaking down tasks into data cleaning, trend analysis, and visualization into reusable modules, you can make your code cleaner and more maintainable. Automating these tasks will save time and ensure consistency across different analyses. To enhance the visualizations, consider integrating interactive plots using libraries like Plotly or Dash. This will allow users to explore the data dynamically. Additionally, you can add functionality to export this visualization as static images or interactive HTML files, making it easier to share and present insights. To take your analysis a step further, you can implement advanced analytic features. For example, you can use regression models for predictive analysis or time series forecasting. You could also apply clustering techniques like K-means to discover hidden patterns in the data. Another useful addition is anomaly detection to identify outliers or unusual trends. Feature enrichment involves adding the ability to work with multiple datasets simultaneously. By comparing datasets, you can find new insights that might not be obvious from a single source. You can also automate the generation of reports, summarizing your findings and presenting them in a consistent format. Shifting focus to the machine learning model, optimizing your model is crucial. Experimenting with different algorithms can help you find the best fit for your problem. For classification tasks, you could try random forest, SVM, or neural networks, while regression tasks can benefit from algorithms like SGBoost or LightGPM. Hyperparameter tuning using tools like Grid Search CV and Randomized Search CV can further improve accuracy. Another key enhancement is model persistence. After training your model, it's important to be able to save it so you don't have to retain every time you want to make predictions. You can use libraries like JobLib or Pickle to store and load your models. Feature engineering is a powerful way to improve your model's performance. By creating derived features specific to your problem, you can provide more useful data for training. Additionally, feature selection techniques like PCA or mutual information can help you reduce dimensionality and focus on the most important variables. Machine learning models can often be black boxes, but it's important to make them more interpretable. By using tools like Shape or Lime, you can explain your model's predictions and understand which features have the greatest impact. This makes your model more trustworthy and easier to debug. Scaling and deploying your machine learning model is the final step. Batch predictions will allow you to handle large datasets more efficiently. Additionally, deploying your model as an API using frameworks like Flask or Fast API makes it easier to integrate with other applications and services. Beyond the specific enhancements for each area, there are general improvements you can make for all types of projects. Ensuring clean, optimized, and modular code will make your project easier to maintain and scale. Improving user experience, whether through better interfaces or real-time progress updates, is also key. And don't forget to focus on testing. Adding test cases and performance benchmarks will ensure your project remains reliable. In conclusion, Day 54 is about enhancing the functionality and usability of your project. By implementing these advanced features and optimizations, you will improve both performance and user experience. The next steps include final testing, documentation, and preparing your project for deployment or presentation. Thanks for listening and best of luck with your enhancements. Welcome to the presentation on the finalization and documentation phase of the Capstone project. In this session, we will go over the key steps taken to wrap up the project, ensure its completeness, and prepare it for handoff. The objective of Day 55 is to prepare the project for handoff, presentation, and future refinements. This includes ensuring that the project is fully documented, functional, and ready for review. First, we focus on code finalization. This step involves organizing the code into consistent naming conventions and clear directory structures. We also clean up the code by removing unused sections and replacing hard-coded values with configuration files. Refactoring into modular functions and reusable classes is key to ensuring that the code is both efficient and acceptable. Next, we turn to documentation. A strong project overview outlines the purpose and goals of the project, as well as the tools and libraries used. An installation guide ensures that the project can be set up easily, while a user manual provides step-by-step instructions for running the project and troubleshooting common issues. Code documentation is crucial for clarity. Inline comments help explain complex sections of code, and docstrings provide detailed descriptions for each function or class. For projects with APIs, automated documentation tools like Sphinx can be used to generate detailed references for developers and users. Testing and quality assurance ensure the reliability of the project. We finalize unit tests to check individual components and perform integration testing to verify that everything works together. Additionally, performance metrics like accuracy and runtime are measured, and we test for edge cases to handle any unexpected errors. Looking ahead, we outline potential enhancements for the project. This includes a roadmap for future features and improvements, ensuring that the project remains adaptable for new use cases. By making the code modifiable and future-proof, we ensure its long-term viability. Preparation for the presentation involves creating a concise summary report that covers the project objectives, implementation details, and outcomes. A clear slide deck with visuals and key findings helps present the work effectively. Additionally, a demo video or live demonstration allows the audience to see the project in action. The project repository needs to be clean and organized. We ensure that the repository uses proper version control practices such as .git ignore for irrelevant files and a detailed readme.md for easy navigation. If applicable, we deploy the project, making sure that deployment instructions are documented for future references. Feedback and viewing are essential to refine the project. We gather peer feedback to identify areas for improvement and integrate these suggestions into the final deliverable. Final validation ensures that all features work as intended and meet the original project goals. In conclusion, by following these steps, we ensure that the project is polished, well documented, and ready for handoff. The final deliverable is now in a state that's ready for submission, peer sharing, or deployment for broader use. Thank you for following along.